this story starts back in June of 2023, when I was at Eurobike meeting up with all the different vendors and industry players who we see at these international bike shows, and two guys approached me out of the blue. They said, "Hey, you're Justin, right? We've got this idea that we want to show you. I think it'll totally blow your mind. It's about freewheeling and regen." Now, normally I'm pretty skeptical about this kind of thing, but what they ended up showing me absolutely blew my mind. This video is going to be a deep dive into Freegen, a super novel concept on how to achieve both freewheeling and regenerative braking in the same hub motor. So it's now been over 30 years that companies have been manufacturing hub motors for electric bicycles, and in that time they've all generally fallen into one of two camps. Either you've got a direct drive hub motor that has the benefit of doing regenerative braking, but that comes at a slight expense that you always have some drag whenever you're pedaling the bike and not using the motor, or they've been geared hub motors that freewheel. So in these motors, there's an internal overrunning clutch that freewheels whenever you're pedaling the bike, allowing the wheel to spin without causing the motor to turn. That means there's no drag on the bike when you're pedaling it, but it means you don't get any benefits of regenerative braking. So regenerative braking is a feature that's heavily touted and adored by every single electric vehicle industry, except the world of electric bicycles.
When you're slowing down, the electric motor is acting like a generator and capturing the energy to put back into the battery.
In the e-bike world, people are generally convinced that it's more important to have a motor system that totally freewheels and doesn't have any extra drag when you pedal on it, over the benefits of regenerative braking, which include no brake pad maintenance and perfectly controllable braking in all weather conditions, not to mention getting 5 to 15% more range out of the battery pack. But now the obvious question is, can't you have a system that does both of those? Can't you just have a clutch inside the motor that you control so that when you want regenerative braking, the clutch closes, the motor spins and you get regen, and whenever you want it to freewheel and spin without any drag, you just release the clutch? And the answer is, of course. There's all kinds of mechanisms you can think of, from solenoids or ferrofluids or centrifugal clutches, that could lock the motor when you want it to be locked and let it freewheel when you don't. The challenge, of course, is implementing that in a way that isn't overly complex. And up until this point, not a single hub motor has made it to market where there's a controllable clutch. So I was puzzling over the patent application drawings that Alan was showing me, and within a couple minutes, everything clicked. This was the most elegant solution you could imagine to this problem of freewheeling and regen. And it took some lone guy living in Israel who'd never actually ridden an e-bike before to see the solution that was hiding under our noses all of this time. So the key to their solution is the mount of the disc rotor. In a typical hub motor of any kind, the disc rotor is attached directly to the shell of the motor. On their system, they've actually mounted the disc rotor to the planet carrier inside the hub. Now, in a typical geared hub motor, the planet carrier supports the planet gears. When you're running the motor spins backwards, the planet carrier can't turn because it's against the freewheel, and that causes the planet gears to force the hub to spin forwards. When you stop using the motor, and the motor itself has a bit of drag, then the planet carrier can spin freewheeling in the forwards direction, and the motor itself no longer needs to turn, allowing that zero drag coasting capability. But if you wanted to have regen while you're moving forwards, you need to somehow lock that planet carrier from spinning. And this is where it should click for you too. So when do you want to do regen? Well, it's when you squeeze the brakes. The disc rotor itself becomes that controllable clutch that was always so elusive to implement elegantly. The existing brake system that's on the bike is now the clutch that controls whether or not the planet carrier is spinning. Once you squeeze the brakes, the disc rotor is locked, the planet carrier doesn't move, and now you can apply a regen braking force and use regen to slow down the motor instead of using the disc brake.
You know, without any modification, it freewheels, right? Justin here locks the clutch, right? We do lock the clutch. He welds the clutch. We lock it not temporarily with the brake.
So it of course, because when the planet carrier is forced to stop turning, then you have power transfer through the planet
exactly
carrier.
Like locking the clutch.
I follow.
When all this clicked, it seemed totally genius, and my mind immediately went into thinking how you're going to control the regen braking force. Now, the obvious solution here is that you would squeeze the brakes to lock the clutch. Now the motor is capable of doing regen, and then you'd have some kind of force sensor on the handle so that as you squeeze harder, the amount of regen current through the motor would increase or decrease in proportion, giving you this modulation. So I was about to talk to Elon about this detail, and he stopped me right away and said, no, Justin, you're missing the best part. Now this next bit is equally mind-blowing, and I need to give a little bit of physics background to try and understand it. So one of the things you learn when you study friction in your high school physics class is that the force of friction between two sliding objects only depends on how hard they're squeezed together, and it's totally independent of how fast they're sliding. If you have a disc spinning slowly or spinning really fast, it's the exact same amount of force or torque that it's putting on the wheel. So Elon's second great insight was this. Instead of letting the disc brakes completely stop at the disc rotor and lock the clutch like a normal clutch would do, he allows the disc to continue to spin inside the pads just at a much slower speed. What this does, it allows the electronic system to actually sense how hard the rider is squeezing the brakes. If the rider squeezes harder on the brakes, normally that would suddenly stop the disc from spinning, but the motor controller can increase the regen force until the disc rotor starts to slip again. If the rider releases the brakes a little bit, then the disc would suddenly want to spin up to full speed, and so the system can similarly reduce the amount of regen force so that again the disc is just very slowly spinning. It allows the control of regen to perfectly track how hard the rider is squeezing the brakes without any actual sensor measuring the squeezing force. And furthermore, because the force of friction doesn't depend at all on how fast the object's moving, the actual braking sensation for the rider is identical to their original wheel, just with a classic normal mechanical disc brake. The fact that it's doing regen is totally hidden to the rider of the bike.
Exactly. So as soon as this is force static and the wheel continues to turn, the rotor turns.
Exactly. Yeah. It's not a digital command to tell the motor to be engaged.
All mechanical based on arresting the rotation.
Like
that's genius. That's genius. Oh, that's so clever.
So how do the electronics know just how fast the disc rotor is spinning in order to do this control loop? Well, it turns out that's pretty easy. Every single geared hub motor already has typically a 6-magnet wheel speed sensor inside the hub. And that tells the motor controller just how fast the wheel is spinning, whether or not the motor is turning at all. Now the motor controller also knows how fast the motor is spinning, and if the motor is spinning at full speed driving through a locked planet carrier, the motor speed should be exactly the gear ratio times the hub shell speed. So by comparing the speed of the hub shell and the speed of the motor, and knowing the gear ratio between these two items, the electronics is able to exactly determine how fast the disc rotor is slipping inside the disc pads. It does this with no extra sensors added inside the hub motor, using what's already inside the system. So when Elon first thought of this idea, he remarkably had never actually ridden an e-bike before, but was just contemplating the challenges that he'd read about with regards to hub motor design and the trade-offs between regen and freewheeling. Keen to try it out, he ordered a Chinese e-bike, modified the hub motor to pass the planet carriers through the hub shell to an external disc rotor, and found an open source controller platform that let him test this control theory. Inside his first prototype, he added super high resolution speed encoders in order to measure the actual disc rotor speed to a very high precision. But in future testing, it turned out that none of this was really necessary. In our current prototypes, it's running just a standard phase runner motor controller using the existing Hall sensors for the motor speed and 6-pulse magnet sensor for the wheel speed. It's communicating the difference in these speeds on a single wire to the super harness that's then able to control and modulate the regen braking to achieve exactly the right level of braking force to keep that slip ratio. But you're probably wondering what happens if the battery is fully charged and isn't able to take any more regen energy. Since this whole system is dependent on putting regen into the battery for the disc brakes to do anything, wouldn't you risk losing your brakes with a fully charged pack? And that's where this system has yet another trick up its sleeve. So recall how I said you would set the system so that the disc rotor is slipping very slowly inside the disc pads, and that allows the control electronics to track how hard you're squeezing the brake, and it means that, say, 95% of the energy goes into regen, while only about 5% goes into the actual friction of the brakes. But that ratio is fully programmable. Just as easily, the disc rotor could be spinning at half the speed of the wheel. In that case, half of the braking energy is going to go into heat, and then only half of it goes into regen and charging the battery. As you keep shifting that ratio closer to having a 1-to-1 unity between the disc rotor and the hub shell, you end up getting close to 100% of the braking force done by the mechanical brake pads, and in that case, there's no energy flowing back into the battery. This system has a super unique feature that not only can you vary the regen force to track how much the disc brakes are being pressed, but you can also control exactly where that regen energy is going. You can divert it, instead of going to the battery, back into heating the disc brakes if the battery is not able to take any more regen current. There's no other system we've seen that has this additional control mode. It can do this seamlessly behind the scenes without any change to the braking force that the rider experiences. You don't actually know how fast the disc rotor is spinning. It will just automatically adjust its spinning speed to whatever the battery is able to handle for regen. So that's all nice and good that the system can divert that regen energy into the brake pads if the battery is totally full. But what happens if you don't have a battery pack at all? If your battery is broken or the motor controller isn't working, surely you wouldn't get any braking force in that situation. And that's where the system has yet another trick up its sleeve. Now you may know that if you have a motor controller and you short the two leads of that motor controller, it effectively locks up the hub motor. This is something people have experienced unintentionally when their motor controllers have failed with shorted MOSFETs, and it's something that can be exploited to give regen braking force even when you don't have a battery pack on this system. In Elon's most recent prototype, he simply installed a relay that shorts out the input of his motor controller. When there's no battery connected or the battery's turned off, this relay is shorted, and that automatically locks up the motor inside the hub. Whenever you're riding the bike and you squeeze the brake, there's a built-in reaction force against the disc rotor. It's not as strong as having a fully running battery that can totally modulate to maximum regen, but it does provide a totally workable, redundant braking system nonetheless, even when you have no working electronics on the bike. So last September, just a couple months after this fortunate meeting at Eurobike, Elon and Michael came to Vancouver with a goal of trying to build a fully live demo of this Freegen system that we could exhibit at the Fully Charged Live show that came through our town. They had custom CNC'd all the components and hardware to adapt our GMAC geared hub motor to have a Freegen coupling so that the disc rotor was mounted to the Planet carrier. It was a pretty amazing feat of last-minute engineering, and in the day before the show, we managed to have a working prototype up and running.
It's a very simple system, and that's the beauty of it. When I'm driving the bike, I'm not sure if you can see this, the disc is not moving. And that's a world first. You've never seen a vehicle where the disc is not directly connected to the wheel.
So as most of you may know, the GMAC motor was designed with a special spline torque arm because one of the challenges with a regen hub motor is bidirectional torque transmission. The axle's turned one direction, then the other way. That back and forth wiggle puts an extra challenge on torque arm design and often leads to failure of regen installations. Now at one point while testing around the block, the bike came back and we noticed somebody had completely forgotten to install the hose clamps to secure the torque arm to the bike frame. Normally, this would have caused an immediate axle spin out the moment you squeeze the brake. The torque arm would spin around 360 degrees in the backwards direction, severing the wires and cable that come out of the motor axle and cause a huge disaster. But here it was doing intense regen, intense acceleration, and the torque arm was sitting there with no hose clamps, just being pressed naturally against the frame. How the heck did this happen? And that's when a final piece of serendipity landed on us. We realized that in the Freegen system, all of the motor torque when you're accelerating is coupled to the torque arm, like on any standard geared hub motor. But when you're braking, all of the regen torque is coupled to the disc caliper on the frame. There's no backwards regen torque going through the motor axle and going through the torque arm. This means that you can use any standard one-way torque arm on the system and not worry about the back and forth axle wiggle eventually loosening the axle nuts or causing other problems. It also makes it much more viable when using the standard hub motor with basic axle flats that's a real challenge to clamp for bidirectional torque. This amazing revelation either further simplifies the integration of Freegen systems in existing hub motor platforms. So obviously being able to freewheel and do regenerative braking is the key selling feature of this system. But it's also got some other perks that make it really appealing to us, especially in the e-bike aftermarket world. The first and foremost is that it lets you install a hub motor system on an existing bike and get proportional varying regen braking without any change or additions to the braking hardware. All you need is a simple digital sensor that detects when the brake levers are squeezed, but that ability to proportionally control and vary the braking is intuitively identical to exactly what you're used to experiencing as a rider. If you combine this with a hub motor that has a built-in torque sensor, it allows for the easiest possible installation, getting a hub motor system with all the features you want, built-in torque sensing control, regenerative braking when you squeeze the brakes, with the least amount of extra hardware to add to the bike that you're modifying. But of course, everything has its disadvantages too. Now, one of the disadvantages of enabling regen this way is that it only works when the disc brakes are being squeezed. Some of the ways of controlling regen that we've come to love, like backpedal regen or speed limiting via regen, those simply won't work because you'd have to squeeze the mechanical brakes in order for the motor to do regen. This also means that you don't have the ability to do some more niche things like having an anti-theft lock on the hub motor so that it's always doing regen if somebody tries to steal the bike and you have to unlock it via a code. And the final downside is that this system only works if the bike frame has disc brakes or at least a disc caliper mount. Any older bikes that are using classic rim brakes or newer low-maintenance bikes with internal drum or roller brakes on the hub won't be compatible. But the vast majority of bikes these days certainly use disc rotors and disc calipers, so we don't see this being a major downside. So I've seen a lot of patents in my life, and it's extremely rare to find something that's a truly original, groundbreaking idea that's not former state-of-the-art and that isn't somewhat obvious to anyone who've worked in the industry. And this is exactly one of those gems. And I feel super lucky to have an opportunity to work with Elon and Michael and help commercialize this groundbreaking idea. So hats off to Elon for having this brilliant insight. It took a guy who'd never actually ridden an e-bike in his life to see what all of us were missing, that there was this elegant solution right under our noses. We're actively working with Elon and Michael of ChargeBike to pursue this project beyond just the prototyping phase and into early stage commercialization. At Eurobike this summer, there's going to be a fully functioning demo e-bike running a Freegen system with the GMAC hub motor that's also been submitted to the Innovation Awards prize. We really hope the judges at the Innovation Awards at Eurobike give it its fair due and don't just dismiss it as another hub motor project. This is a really one-of-a-kind invention that's fully worthy of all the accolades you can imagine. We're also working on building a prototype around the smaller Sheng SX motor series. Now, these motors have the advantage of using a helical cut gear, so they're more silent in operation, and we think that that slightly smaller but still decently powerful hub would most likely be the ideal choice for most people who are drawn to a totally freewheeling motor system that can still do regen. So stay tuned to the years ahead. This is one of the most exciting and unexpected pursuits that we've had land on our plate here at Grin, and we really look forward to bringing a whole new category of hub motors to the market.